So if there is anything to listen to hear, that will be here. So I will just show you. That's an overview of what was there, and we'll talk about that. And that's the YouTube video. And that's the YouTube video. And let's see.
Teaching quantum computers how to simulate a problem from particle physics is like a very, very active field. Like it has grown like really exponentially.
Yeah, that is a very, very smart lady. Here, I'm closing that. So I will say, if you have the time, go and listen. But what she's talking about is right here. So let's go. Let's see what people are talking about. It shows it right here. That's fine. So our host, Dr. Zlatko Minim from New York, and Christine Mushek is originally from Germany. But what is she talking about is quantum chromodynamics. Now, to me, that was the first time I even heard such a thing, and it is the theory of quarks on gluons. Well, doesn't help. But I'll tell you in simple words, how do we investigate those particles? Remember those electrons and protons and photons, these particles. How do we investigate this? So there is one way to investigate them is by imitating them on computer. And that was, I believe, the Richard Feynman who said that the very first thing. He said, if we want to investigate how those particles behave, we need a computer based on that. We need a quantum computer to investigate quantum physics. And that is his idea in the first place. Now, it turns out that there are very basic particles. There are particles called quarks like this, right? Quarks. And these quarks compose other particles. So, for example, protons are made out of them and electrons made out of them. The amazing thing is that these quarks are big. They are bigger than the electrons, but if many quarks combine together, that becomes a smaller particle. But everything there is quite amazing in quantum physics, right? Now, this is not quarks. This is tetraquarks, new things. They discovered them, and they usually discovered them by doing theoretical research, and then they try to actually observe them. Of course, there is no microscope that will allow you to see them because they're smaller than electrons that are used in electron microscopes. But instead, they hopefully produce them in their supercolliders reactors, and that's what she's talking about. Now, that's not very practical for us, but it's still interesting. I like to listen to very smart people, and that's what the case is. So she talks about QCD. Now, what is this QCD? Because she's talking about a theory of QCD, and then talks about how quantum computers maybe can help. QCD is discussed right here, QCD, and that stands for quantum chromodynamics. So that's what QCD is. Well, okay, but it still doesn't tell me what it means. So what I did, let's close that. What I did is I went to ChatGPT and I asked, what is QCD? And that's what he told me. By the way, when you are in ChatGPT, you can take the link and send it to all your friends, and it's open. And I have actually put it right here. That's the one. That's what will open. And note that it is not your regular ChatGPT. Now, if you go to ChatGPT here, then there are multiple conversations with ChatGPT, and it's here. And if you want to send this conversation like this one, UCD, to somebody, you click on this link. That works as Bitly. It creates a permanent link that you can send. It also makes a snapshot of what's here, so it's not part of the conversation. I can close that. I can simply open that in its own window and read what QCD are about. So with a QCD is a way of, it's a theory of theoretical physics. That's good enough for me. It's a theory. But she talks about that there are two ways to build this theory. From what I could understand, way number one is called perturbative QCD, but it assumes that all those particles are close and the energies are high. So when the particles are close and when the energies are high, you can take a derivative. In other words, you can move the particle just a little bit and then see what happens. That's easy. That part, perturbative QCD, and you can throw them around at the party and that will earn you great kudos. But perturbative QCD is when the particles are close and when the energies are high, and that's how you do this investigation. So because you can take a derivative of your formulas, it is theoretical. You can solve these things in theory. But when the energies are low and when the particles are not that close, things are more, how would we say it? They're not continuous, they're discontinuous. You cannot solve it as a theoretical equation, and instead you have to use an imitation. That is where protons, neutrons, and other hadrons, and I didn't even know there is such a Phineas hadron. I know one company called Hadron, but that's where these come in. And you best of all, you do them on a computer, on a quantum computer. All right, that's enough. That is what she's talking about. Okay, so let me pause for a second. And welcome new people who just came. So what I will do is increase my window somehow, yeah. So we have new people here, and because we have new people, I need to stop my video. That way you don't look at the screen. No, it's not the video, it's my share. Stop share. Okay, and with that, I can say, hey guys, and hey Charles, and I will give you permission to talk, and also Michael. Now to know. Okay, so what we've done is we looked at what's new, what's interesting. And in this case, we're lucky. Somebody is talking right now on the next IBM seminar. And so that's what we will be able to discuss next week. So any questions, interrupt me anytime if there are any questions. Now let's go into the practical part. Share the screen again, share it with the sound, if there is any sound. And here we are. Okay, so the next thing is just a few minutes before we talk, guys, just before a few minutes before, I got finally the certificate voucher. That means I have to bite the bullet and take the test. So I invite everybody to do this. You remember I offered to pay for your test once you pass it, but I will be investigating this. So practically, that means that there is a great program and I'm going to go through that program and you can go with me. You don't have to become Qiskit advocate, but if you want to prepare for the exam, that's what you can do. Now, I have already prepared a repository right here. So let me open that repository. Okay. And that repository right now just has the documentation, but it's great documentation. It turns out that there's a study guide and there is a certification syllabus. Okay, and then there will be code labs, but that's next time. So if we look at the study guide, I showed this to you last time, but this time I'm going deeper into this. That's the difference. So don't be deceived that it's a picture. It's not a picture. It's full screen. And if you go full screen, then you can use arrow left and arrow right, like this. Arrow right, arrow left. To me, it's not obvious, but now that I told you the secret, you can do arrow left and arrow right. And I found an amazing amount of good material. Now, these are corporate statements that don't blame us for anything. But this guy is James Wither, a great guy. One particular thing that I noticed is his book right there. So we'll be back to this book. It's just published, maybe last year. So it's quite current, and things don't change all that fast in here. So it is completely current. If so, let's look a little bit more about what he is talking about. Here, he is talking about that, hey, we all know, honestly, that there are no practical applications, even though they are announced like every day that there is a practical application, but no, not yet. But nevertheless, get ready for that tomorrow, today. That's the idea, and that is how I position it now. I'm teaching it. It's one of the major tech corporations, and I'm really scheduled to do it sometime in October to teach, prepare for the future now. Okay, but I myself, I want to go through the exam, and there are 60 questions and 44 you need to pass. And now they go into, I'll give you some examples. So last time, what I did is I showed you questions, and these questions were not easy. All right, here. So it's a nice block sphere. Okay, that's all nice, but let's come to the questions. That's the environment. I will take you through the environment. If you go on this journey with me, I will actually take you through my lab, and it will be all there. And my cat came to greet you, as you see. All right. But here is the first question. So the 20 questions, that's what he shows you. And we looked at that. Good. So everything is ready for you, but somebody needs to cook the dish before you can eat it. Like, for example, there's a question: what do you do with quantum circuits? And I noticed one very important thing. Yes, he gives an answer. You can study the answer. You can also go through the code. And nevertheless, that's not enough. That is not giving you the understanding. But I discovered that his book is actually giving you understanding. So let's go back. So it looks like if he wanted to promote his book, with this, he succeeded. Right here. We're talking about this book, and he might notice that, yes, I bought a copy. Now, I'm making it small, and somewhere here, there must be a link to the book. So I want to show you the book, what it consists of, and start doing some of the book with you. So that is called Qiskit Pocket Guide. That is Amazon Reader. It's Kindle. So that book I found it's better than just going through the explanations and labs. Because in the very beginning, he states, well, guys, you need to understand something. You cannot just go through mechanics. Yes, that's how you create them, but you really need to know a little bit. And that's the first chapter. So quantum computing is talking about that there is quantum physics and there are quantum particles, and you can use them for your computations. And these are called quantum operations. But then he goes about, I will explain it to you. That's what he does here. So he says that there are quantum circuits, and that is what you use as your computer. So if you want to do some quantum computations, first you procure a quantum computer. And it turns out that you build a computer for your purpose. For example, if your purpose is very simple, some kind of basic operations, then you build a very small computer. How do you build it? Well, it's in the cloud, it's a service. You borrow a few qubits. That's what you do. You borrow these qubits by creating a quantum circuit, and that will be your computer. So you're kind of slicing a little bit of computing power, quantum computing power, in this case, 2 of something and 2 of something. Then he explains that those 2 of something is 2 qubits. And we'll be back a little bit about refresh. What is a qubit? But another way to say it is 2 and 2. So that's the same. These are the same equivalent ways of saying it, except that this quantum circuit 2 says you need 2 qubits, and it will also have 2 regular electronic bits, but it's not mentioned here. Here you can spell this out. What that means is that your qubits will be doing the computations. And we remember these qubits are done by super frozen, even though there is work to make it not so frozen, but super frozen, let's say, ions, that's one way, or photons, they're not frozen, and so on. But they work in darkness. They don't show you how they work. That's the whole secret. They can do their magic when you are not looking. But then in the end, you want the result copied out to some regular device. That is the other 2. That is the regular bit. And so whatever you calculate on this qubit is then translated or copied into regular bits. That's what he starts with, right? And after it is copied, then, as they say, the system collides. It's not good for any more computations. You will have to prepare another system. That is basically how it works. But then he explains how you use this class. And now you can read it here, how you say it. It's quantum computing, it's quantum circuit. But now you can do your operations on each individual qubit. Now that is very quick. That's not an explanation. So you will go further, right? And you will start explaining what it really means. So it is the format of a pocket guide, but that pocket guide has enough of the explanation. And what that shows is that you take a qubit, that's a qubit 0, and then you apply different transformations to it. For example, nonsensical circuit, that it doesn't do anything reasonable, but it shows you how you can operate on quantum bits, on qubits. So this is an Adamar circuit, Adamar operations, and what it does is to take the qubit, this one, in a definite position and translate it into a what's called superposition. And superposition is your qubit when you don't observe it. So it is possibly here and possibly there. But practically, you'll start by running a simulator, so it will only pretend that it doesn't know where it is really. It will know because it's a simulator. And the real computer, that will not know. So that is the first operation. Then he shows a few more operations, which are nonsensical, so we're not interested in specifically what they do, not today, but we show how that works. So you do the operations on the qubits, and then finally you measure them. He will show that how you measure it. He will explain what the names of that things R. And then I expect that he will give us a diagram like this, where he shows these operations applied to our qubits, and in the end, measures the results. So that will be somewhere right here. That's the measuring the results. That is why you need regular bits in addition to qubits. So that was the take my qubit, do something to it, and then measure the result. Okay, so I showed you the plan. The plan is to use all these links. One link leads to the repository. The other link leads to the information in this repository. Let's close the book, because not everybody will buy a book. It costs, I think, $10 or about that on Kindle. So I think if you really want to take a test, it would make a lot of sense, because you'll spend a lot of time figuring out how to do this test and what do they mean. But here is the nice slide deck. So first level is you learn about what's on the test. Second level, you go through his slide deck, but I think his slide deck will really require that you come back to it a number of times. And then finally here, that is the book. Now, what I have for you guys is that I'm going to go through that. I'm going to go through next chapter. And so for the next meeting, I want to go and do the exercise. So the first exercise, in other words, that's what I want to do. So I won't do it very cleanly now, but I'll say that that's for the next one here, 21st, and that will be the latest news. And by the way, that will probably be the next one, 129, and that will be the news with some explanation of that news. And then the next one is step, if we say that this now is step 0, this was step 0. Plan. Then that will be step 1. Step 1. With more explanation on what that step means coming. All right. So I'll stop sharing again. I see that there is a comment here which says, hello, great, wonderful. Okay, that's what it says. It was on chat. And now is your chance to ask questions or express some desires. I'll do it like this. I'll talk to everyone and I'll say questions or requests. Now, since we don't have any questions or requests, what is the fee? I expect it's around 200. It's either 150 or 200. That's what they all are. So honestly, you are risking something. If you're registering for the test, if you pass, then I refund. And if you don't pass, you lose, right? But I think that it's a great push, right? Okay. A great push for me too. So let's see, we have a few more people, maybe. Yes, we have Ken. And let's do this. Allow them to talk and give them a couple minutes, a chance to talk. So if you want to talk, good. But if not, let's hope that it will be good for you guys and for me. And I'll see you next week. I apologize, it's shorter today because I have another meeting about AI. All right. So thank you very much. It was a pleasure trying to absorb the information. Great. Don't forget that that link is always there. This one. So let me give it to you again. give it to you on chat here. Here. That's a permanent link, and that's a record of all that we do. So yes, you will be able to absorb the information. I will honestly tell you that I had the same problem. Absorbing that information is taking time. It's not that it is unbelievably hard, but it does take time to just get used to those particles and what they do when you don't see. All right. Thank you very much, everybody, and be well.